Today in the workshop, we'll take our first look at touchscreen displays. I'll show you how touchscreens work, and then we'll start with an inexpensive Arduino touchscreen shield. We'll run a bunch of demo sketches, and then we'll program some buttons of our own. It's been a while, but we're back in touch today, so welcome to the workshop. Hello and welcome to the workshop, and today we are going to be working with a touchscreen display shield for the Arduino. Now, if you saw the video I did last time about all the projects I'm going to be working on this summer, you'll notice I had a number of different touchscreens. The one that we are going to be using today is a very inexpensive touchscreen shield that is commonly available. I got mine on Amazon. You can get these on eBay, and if you have a locally stocked electronics parts store, you can also get one over there. They're very inexpensive, and as you're going to see, they're not that difficult to use, but you need to get a handle on the fact that you're actually not working with one item, you're working with three of them. The touchscreen display shield that I'm using today is pretty typical in the sense that it actually has three separate components. There's the display itself. It's an LCD display. It's called a TFT, or thin film transistor display. There is the touchscreen membrane that sits on top of the display, and on this particular one it's a resistive touchscreen. I'll explain the difference between that and a capacitive one in a few moments. And there's also a micro SD card on the board, and that can be used, as you're going to see, in order to store images and things that you would like to display on your display. So when you're interacting with one of these, you're really interacting with three different devices. Now I've got the device over here right now. You can take a closer look at it if you wish over there. It's a very simple shield for the Arduino, and as I said, this is a particularly common model over here. Now, this shield is made for the Arduino Uno or the Arduino Mega, although as you're going to see, when you're using it with the Mega, the SD card is not going to work because it uses the SPI bus, and the SPI connections on the Mega are different than the ones on the Uno. So there are a number of these small displays available. This one is very common. There are a few other ones, and one thing I want to show you is a great resource that I ran into on the internet for getting the information and drivers for virtually any LCD display, touchscreen or not. And this is for both the Arduino and the Raspberry Pi. So we're going to take a look at that. After we do, we're going to get the software for this particular display, and I'll run through a number of the demo programs to illustrate the capabilities of the display. Once we do that, we'll write our own code so we can create a simple user interface and control things with our touchscreen display. So as usual, we have a great deal of things to cover today, so let's start by learning a bit about touchscreen displays. Now let's take a look at the technology behind touchscreen displays. The first touchscreen was invented in 1965 in the UK by Eric Johnson. The original use for this screen was for air traffic control, and by the way, the original touchscreen did not cover the entire screen and could only be touched in one location. Touchscreens are now used in a myriad of different products. There are two main types of touchscreens in use today: resistive and capacitive screens. Resistive touchscreens are inexpensive and very common. They consist of two thin layers or membranes separated by a small gap. The top layer is flexible and also transparent. The bottom layer is a solid layer. The conductive side of both layers face one another. If you press on the top layer, it'll change the overall resistance, and this is used to indicate a touch. There are three types of resistive touchscreens that you'll run across. The simplest is the 4-wire analog touchscreen, where each layer has two wires. These are often called the X bus and the Y bus, and this is the type of touchscreen we'll be working with today. The 5-wire analog has 4 wires on the top and 1 on the bottom. It allows multiple touching with this arrangement. 8-wire analog screens are more reliable than the 4-wire variety, but use the same principle. Capacitive touchscreens are made of a transparent conductive material. This material is placed upon a glass surface. Electrodes are attached to each corner of the material. Touching the glass with your hand initiates a current flow. Due to your hand capacitance, the current will try to find a route to ground through you. Sensors underneath the screen measure the change and the location of it. The advantages of resistive touchscreens include that they are lower cost to manufacture. They have a higher sensor resolution than capacitive screens. They also have fewer accidental touches, as you need to physically press the screen to register a touch. You can use gloves to use a resistive touchscreen, although it should be noticed that there are special conductive gloves that you can use for capacitive screens. Any hard object can activate a resistive touchscreen, so you can use a stylus or your finger. Resistive touchscreens are more resistant to heat than capacitive ones. Capacitive touchscreens are more durable than resistive ones. They can even function with small cracks in the glass. Because the material they use is more transparent, they produce sharper images and also produce better contrast. Capacitive touchscreens can also use multi-touch sensing, allowing you to use 2 or more fingers on the device at one time. This is often used in tablets and phones and cameras. They're more reliable than their resistive cousins, and capacitive touchscreens are also more sensitive. So now let's start working with touchscreen displays. Let's take a closer look at the 3.5-inch LCD touchscreen shield that we're going to be using today. Now, this is a very common device available from a number of different manufacturers. If you look at it on the bottom, I'll turn it around this way, you can see that they've labeled off what all of the connections actually do. And if you look, you'll find there are very few connections left over on an Arduino Uno. Digital pins 0 and 1 are not being used, and analog pin A5 is not being used, but other than that, it uses pretty well every pin on the Arduino. Now, you'll also notice a micro SD socket over here. We can just take a micro SD card and insert that in there, and this would allow you to have a micro SD card which you could use for images that you're going to use on your display. Now, the display also came with a little stylus over here that you can use to press on the screen, or you can use your finger, of course. Now, I'm not sure if you can see this, but if you look on the side of the display, you'll see 2 different film cables. The top one over here is the one going to the actual touchscreen. These are the X and Y bus connections, and this is a 4-wire analog type touchscreen, so there are 4 wires here. These lines over here on this film cable are the ones that go to the LCD display itself. So it's a very simple looking device, but as you're going to see, we're going to have to write a bit of code to use it, because remember, we're actually looking at 3 devices: the touchscreen itself, the liquid crystal display, and the micro SD card. And so let's start working with this. So now that we're all experts on the LCD touchscreen, it's time to put our little touchscreen display shield to work. And in order to do that, we're going to try to gather a little bit of software. Now, what you're going to need when you're working with a touchscreen display shield, be it this one or any other one, is you're going to need to get a few specifications so you know things like pinouts, etc. Now, for a shield, that's of course not that important because you just plug it into the Arduino. But if you're wiring this independently to another processor, you would need to know that. So a data sheet is something you're really going to want to get a hold of. Another thing you're going to want to get a hold of when you're working with the Arduino is some libraries. Now, you'll need a library to drive the LCD display. You can drive it directly, but it's a lot easier to do with a library. You'll also need a library to read the touchscreen membrane. And since it has a micro SD card, there are a couple of existing Arduino libraries that we can use to work with that. Now, getting all of that software can be accomplished a number of ways. When you buy one of these touchscreen displays, it quite often comes with a tiny little CD that has a lot of this on it, and that's really great. The only thing, of course, about a CD is you tend to wonder if you're getting the most recent version of the libraries, etc., because the CD might be a couple of years old. You'll also probably find a link with your display to the vendor's website where they will give you a number of these files as well, and the website files may indeed be updated more frequently. But I've got another resource for you that I think you're going to like even better. Now, the resource is called the LCD Wiki, and as it implies by its name, it is a wiki that covers all sorts of liquid crystal displays, be them touchscreen displays or non-touchscreen displays. And it has libraries and it has data sheets for all sorts of displays, not only for the Arduino, but for the Raspberry Pi. We're talking about shields, we're talking about hats, and independent displays that you would wire up to your processor with discrete wires. So I'm going to show you right now the LCD Wiki. We're going to use it to grab the software for our touchscreen display, and then we're going to quickly go through some of the demo software that they give us. So let's take a look at the wiki right now. Now, this is the LCD Wiki, and you'll literally find this at lcdwiki.com. And this is an excellent resource for using liquid crystal displays with the Raspberry Pi and the Arduino, as well as a number of other processors. Now, on the main page of the wiki, you'll get a number of things such as the About section and all that. Here's a number of getting started articles. Some of these would be really handy. How to use Raspberry Pi downloads, how to install the drivers, how to calibrate a resistance touchscreens. There's a lot of good stuff over here. Then it goes into the individual displays. First of all, some Raspberry Pi HDMI displays, ones that connect directly to the HDMI port on the Pi. Then another series of Raspberry Pi displays, ones that connect onto the display connector, ones that connect onto the GPIO, and then we get into our Arduino displays, a number of different displays for the Arduinos. Then some OLED displays, some SPI connected displays, and some parallel port displays. So you'll see there is a wide variety of LCD displays that they have information on. Now let's go into the Arduino ones. Now the 3.5-inch Arduino Uno is the display that we will be using, and so this is the page that it takes you to when you select that. Now this is typical of all the LCD displays, so if you've got a different display, you'll find a very similar page for it. It gives you some pictures of the product, the description of it, the parameters, the pinouts of the product. This can be very important when you're trying to wire this to a different processor, like let's say an Arduino Nano using jumper wires. And a number of documentation links, the user manuals, pictures, specifications, and data sheets, etc. for the driver IC. Now some instructions for actually connecting it onto the Arduino and using the software libraries. So if you need some help with that, that's right over here. And then what we're really looking for, the program download. This is a zip file that you can download with all the libraries and examples that you need. So download this file, and the next step will be to install it onto our computer and to start running the demos. So now that we've downloaded our software from the LCD Wiki, I want to go through a number of the demo programs that they include with the software. Demo programs are a great way not to only display the capabilities of the device, in this case the LCD touchscreen display, but they're also great for writing your own code, because you can look at the samples they use and modify them for your own purposes. Now there are a number of demos here, and I don't want to go through the individual code and then run the demo for each of them, because that'll make this a 2-hour video, and I don't think we really want that. So I've gone through all of the demos, and I've got a little presentation of them right now, so let's take a look at that. After downloading the zip file from the LCD Wiki and extracting its contents, this is what you're going to end up with, a series of directories. Now, before we can run our demo software, we're going to need to install some libraries into our Arduino library. So this is how we do it. The first thing we do is we want to go to the demo directory. So we'll go into there, and since we're working with the Arduino, we're going to go into demo Arduino. Now you'll notice two folders here, Example and Install Library. You'll also notice there's a couple of PDF documents with instructions, so if you need some further help, it's right there for you in both English and Chinese. We want to go to Install Libraries to get our library, so we go into there and we will find 3 libraries all in their own folders. Now where you install those will be the library directory in your Arduino directory, and that location will depend upon your operating system. As I'm using Ubuntu Linux, my Arduino directory is in my home folder, but if you're using Windows or a Mac, you will find it in a different location. By the way, your Arduino IDE can tell you where the directory is. So let's go and take a look at mine right now and how I've installed it into my Arduino directory. So let's split my screen over here. And let's go over here and go to the home folder. And here we have an Arduino folder. In the Arduino folder, I've got all of my Arduino programs. If I go down here, I'll see a folder called Libraries. And in the Libraries folder, I have a number of my libraries. And as you can see, I have installed the 3 libraries from here into this folder. And that's all you need to do is to copy them in. Okay, now back onto here, let's go and get the examples. So let's close our split screen. And we'll go back to Demo Arduino and we will see Example. And under Example, we will see all of the different examples. Now these can be copied again directly into your Arduino directory if you wish, and you can run the examples one by one that way. So here's a summary of the demo sketches included with the LCD display software. Example 1 is the simple test. This test doesn't use any of the libraries you installed. It drives the liquid crystal display directly. The test is a simple color sweep. In this case, the touchscreen is not used. This is a good test just to determine if your hardware is functioning correctly. Example 2 is the clear screen example. This uses the graphics library and also uses the helper library, the one that takes the specific configuration of the LCD display hardware and maps it to the graphics library. This test is also another color sweep. In this case, the speed of the sweep will vary during the test. Example 3 is a comprehensive test. It uses the same 2 libraries. This test displays the graphics capabilities of the display. It draws a series of geometric shapes. This test runs for a very long time and then repeats. At the end of each cycle, it will give you the results on the screen. Example 4 is the display graphics test. This also uses the same 2 libraries and, like the previous test, displays the graphics capabilities. Unlike the previous sketch, the shapes are displayed in the setup, so they're only displayed once. The loop of the program displays a series of text messages, and they'll run continuously until you stop the example. Example 5 is the display scroll. Again, it uses the same 2 libraries. In addition, this also uses an external font file. This shows text in 2 languages, English and Chinese. It displays multiple colors and changes the orientation of the text. Example 6 is the display string test. This uses both libraries. It simply displays text in different sizes and colors. This is an excellent example for learning how to drive the display and to add text to it. The Read Pixel example uses both of the libraries. This reads the pixel color values. During the test, the background will change and the orientation will change. The test might seem a bit cryptic until you stand far away from the display, and then you will actually see the characters that are being displayed and their color values. Example 8 is the display phone test. This uses both of the libraries we've been using, and this is also one that uses the touchscreen library. This is a telephone keypad simulation, and it's fairly functional. the touchscreen is used, and when you touch a number, it'll display up on the reading at the top. There are also keys to delete and to make the call and to end the call, although of course the call keys are just simulated. There is no real phone happening over here. Example 9 is to show a bitmap picture. This uses the same two libraries we've been using for all of the tests. It also uses the Arduino SPI and SD libraries. You'll need to put your bitmap images on a micro SD card. These images will be drawn on the display. Again, this is excellent code for learning how to display images from the SD card on your display. Example 10 is a switch test. This uses all three libraries, so it includes the touchscreen library. It also uses an additional font file. This draws a series of switches and buttons which are actually active. You can use your finger or a stylus in order to activate this. This is a very good example code for designing a user interface. Example 11 is the touch pen example. This one also uses all three libraries. And what this test is actually a functional drawing application. You can select color and pen size. This is an excellent sample to show you how to make an advanced dynamic menu on the display. And finally, we have the touchscreen calibration. This sketch uses all three libraries. It starts by providing a number of calibration points. You use your stylus to select the center of these calibration points. The results it displays can be used in your future sketches. You'll probably run this many times to get the most accuracy. So as we've seen, there are a lot of very interesting demos included with the software package that we got from the LCD Wiki, and we can use the code in those demos as example code for writing our own touchscreen interface, and that's exactly what we're going to do right now. Now, the interface I'm going to build right now is fairly simplistic, and is just going to use a couple of components. I'm going to use this one, however, with an Arduino Mega, and that's because our touchscreen really is taking up just about every single pin on the Arduino Uno. In fact, the only pins that are left over from the touchscreen are pins 0 and 1, which are also the pins that are used for the transmit and receive on the USB connector. So we don't really want to use those if we can avoid it, because whatever we connect we'll need to disconnect in order to upload updates to our sketches. The only other pin available is analog pin A5, which of course could be used as a digital pin as well, but if you need more than one external pin, then an Arduino Mega is really a good idea because of all the extra analog and digital I/O pins. It's also fairly easy to get to the pins on the very far end of the Mega when the touchscreen shield is in place. So we're going to put our touchscreen onto a Mega, hook a few extra components up to it, and build our own touchscreen user interface. Let's get at it right now. For our experiment, we'll be using an Arduino Mega. We'll also need 3 LEDs. I'm using a red, green, and blue one, but you can use 3 different colors if you wish. You'll also need a dropping resistor for each LED. I'm using 220 ohms, although any value from 150 to 470 will work. We'll begin by connecting the ground connection from the Arduino Mega to the cathode pins of all the LEDs. We'll then connect the anode pin of the red LED through its dropping resistor to pin number 44. The green LED through its dropping resistor will go to pin 45, and the anode of the blue LED through its dropping resistor to pin number 46. Finally, we'll place our shield on top of the Arduino Mega, making sure to align it correctly. And this completes the hookup. Now let's go and take a look at the sketch we'll be using to drive our LEDs and control them with the LCD shield. So now let's take a look at the sketch that we'll be using with the 3 LEDs that we've hooked up to the Arduino Mega with the LCD touchscreen. Now we're going to be using a number of libraries from Adafruit. These are very common libraries to be using with touchscreens, and a lot of the code for this came from an example that they had to do a phone demo, similar to the phone demo that we saw earlier. And so what I've done is I've just taken out 3 of the buttons, changed the color on it, and set them to toggle the LEDs on and off. Now this is a very basic demo, but it'll show you how the basics of working with a touchscreen goes. So first of all, we need to include 2 different libraries from Adafruit. The core graphics library over here, which is used for a number of different Adafruit graphics projects, and the LCD library, which defines the LCD itself. Now you can get both of these using the library manager in your Arduino IDE if you don't have them already, so you can go grab the latest one. The touchscreen library we've already used, and it was included with our touchscreen display, and we've also downloaded that, of course, from the download we did from the LCD Wiki. The MCU Friend is a hardware-specific library for a number of different touchscreen display shields. And so what it does is it goes through and identifies which shield you have and spits back the proper parameter. Now, there are a number of ways you can get this file. You can't get it on the Arduino Library Manager, but there are several sources to download it from, including the LCD Wiki. I'll also show you some sources on the article that accompanies this video on the Dronebot Workshop website. Okay, so once you've called all your libraries and included them, we have to start defining a number of things. Now, we define a number of the pins that the shield is going to be using connected out to the Arduino. So just basically take these as these are because they're hardwired onto the shield. Then we're going to assign names to a number of different color definitions. And I've included the entire list that Adafruit provided in their demo code, even though by no means are we using all of these colors. For that matter, they weren't using them either. But these are just good to have, and you can play with the colors later on if you want to change the colors of the buttons or the background, etc. And we've just given them all human-readable names. And so down over here, we start working with the user interface, and we define a number of parameters for the user interface that just determine the size of the buttons and the text, etc. Then we got to define the pins for the resistive touchscreen. Now remember, our touchscreen uses 4 pins, 2 of them on the Y side and 2 on the X side, and we're trying to measure resistance between all of these. Now, these 2 here need to be an analog pin because these are the ones we'll actually be using to measure resistance. These ones are digital pins because these are going to be the output. We're actually going to send out 5 volts and then measure the voltage we get back on the other pins here. And that's essentially how we determine where the touchscreen has been pressed. We just see the voltage difference between the X's and the Y's. And we can figure that out as to what coordinates it is. Okay, now a couple of pressure points. These are parameters that you can just take as they are right now. You can adjust those if you find that your touchscreen isn't responsive enough or is perhaps too responsive. And then these parameters over here. Now, if you remember, we ran through a test sketch earlier during the demo in which we could go and calibrate our touchscreen and get a number of different values. Well, these are the values that it spits back. You can run that sketch and change these values if you wish, or you can just take the values right now, which are pretty generic and should work for a demo like this because our buttons don't have to be too precise. Okay, then we define the LEDs themselves, and they're on pins 51, 49, and 47. You could use other pins if you want. I did choose those pins because I intend to take this same setup and write another sketch down the road in which I can control the brightness of the LEDs, and these 3 pins happen to be PWM pins. But for this particular sketch, we're not using PWM, and you could use different ones if you want. These pins are pretty easy to get to, though, with the shield on top. And then we also define a couple of booleans over here, and these are the state variables for the button. Remember, we're going to make these toggle. So this just holds the previous value of the button so that we know what to turn it into when it's pressed, whether to turn it on or off. And they're all set to 0 to start off with, which would be having all of the LEDs off. Now we define an object to hold the buttons themselves, a button array over here, and we create a couple of arrays with both the labels of the buttons, the R, G, and the B, and the 3 colors. So if you wanted to change the labeling or the color of your buttons, you would just modify the code down over here. We'll also use an object over here. We define one for the TFT using the MCU friend library of TFT displays. And TFT just means thin film transistor. It's another word for the LCD display, so that's an object that represents it. And an object for the touchscreen on top of the display itself. Now these parameters already we have gotten previously in the code. This last one here, 300, is actually the resistance in ohms between the X and the Y with the screen not being pressed. And if you wish, you could take your touchscreen and a multimeter, measure your resistance, and change this to make it a bit more accurate. But 300 is a pretty standard value, and that is what most of these touchscreens are manufactured to be defaulted to. Okay, now we'll go into the setup. Now we're going to use our serial monitor just to observe the buttons being pressed and released. And so we'll set it up at 9600 baud and print a little bit to it. We'll set our LED pins up as outputs right now. And we'll reset the touchscreen display, the LCD display with the TFT reset over here. Now we need to identify the display itself. So we'll read its ID, and depending on the identifier that we find over here, we'll print this out to the to the serial monitor so we can see which LCD driver it has found. In some cases the identifier is going to be a little bit different, and we change it down accordingly, but this identifier is just used just so that the display libraries know the size of the display, etc., etc. And so assuming we've identified the LCD driver chip we're using, we get through that. Then we set up the display itself. We begin the display, and we know the identifier number now, so we know how to write to it. We print out on the serial monitor what the size is, because we know the identifier, we'll know the width and the height of the display, so we'll know what size our display is. We set the rotation. This just sets it up right now into portrait mode. If you wanted to set it in landscape, you turn that to a 1, and we fill the back of the screen, which I'm filling with black, but again you could change the color just by changing this here, and this goes up to one of those human readable colors we defined earlier. Now we draw the buttons, and the buttons are just basically members of an array, as you recall, so they're all mathematically related to each other by their space and their width and all that. And so this whole bit over here, which again I borrowed from the Adafruit code, just allows you to define the buttons, and you can change the parameters of some of these further up in the code if you wish to change the size of the buttons. Okay, now we go into the loop. Now we need to toggle pin 13, which is being used to send a pulse out right now to the display. And so we'll toggle it over here. And then we need to set those pins that we're using for the X and the Y to outputs right now. Now you might think it's kind of different setting pin mode up in the loop and not setting it earlier up, let's say in the setup or even before the setup routine when we define the pins. But the reason we do it over here is that we need to actually redefine that every time that after we've done this pulse over here, because everything kind of starts from scratch. If you don't do this, try moving this up into the setup and see what happens. You'll notice the display will flash every time that you press it, and it gets quite annoying. So that's why this is down over here. Then we have to determine if we've at least hit the correct pressure, and we've gone over here to map that pressure and find out the exact value of the X and Y coordinate that has been pressed. And we go through the buttons now to see if they relate to those coordinates, and if they do relate or within a value of 10 of those coordinates, we know a button's been pressed, and we get the value of 0, 1, and 2 depending on which button has been pressed. So button 0 would be the red button. The first thing we do is we take that status boolean that we had and we toggle it to the opposite value. So we do it with this statement here, and if the second button was pressed, which is button 1, that would be the green. The third button, button 2, would be the blue. So we change the state accordingly of its boolean. And then we go to the button display and we take a look at that state. Now if these are set to a 1, then the light should be on. So if the red is set to 1, we'll turn the red LED on, or otherwise we'll keep it off. Same deal for the green and the blue. So we go through that and see which lights need to be on or which need to be off. And then after that, we'll just go through and look at the released event over here, printed out on the serial monitor, and we'll just draw the inverse on the button because we want the button itself to react to the fact that it's just been released. I'll put a slight delay in here for debouncing, and then we'll go up and run the loop all over again. Now I know there's a lot of code over here, but if you break it down section by section, you can see how we're dealing with the display, because remember, we're dealing with both the LCD display and the resistive touchscreen on the top of it, so we're really dealing with two different items over here. So now that we've seen the sketch, let's go and take a look at it in action. Okay, so here's our display. As you can see, it's a very simple hookup. I've got the shield on top of the Arduino Mega, and the red, green, and blue LEDs through their associated dropping resistors are connected to 3 of the I/O pins on the Mega, and you can get at the I/O pins on the very end of the shield without adding an extra adapter or anything, so that's very handy to be able to do that. Now I've also got my serial monitor up. As you can see, it's already displaying that it's done the LCD test. It's found the correct driver, and it has determined the resolution of the display as well. So all that's left to do is to press some buttons and see what happens. So let's press the red one. And as you can see, of course, the red light came on and it stayed on. And you'll see on the serial monitor that the event of both pressing button 0 and releasing it has been recorded. Let's do it again. And we'll see again we've recorded another pressing and release event, and the light is turned off. It's toggled, and of course this works with all of the lights. And so you can see on the serial monitor as I'm doing it, the events are being recorded, and of course the lights are doing exactly what we would expect them to be doing. Now, if you wanted to, instead of hooking up 3 independent LEDs, a red, green, and blue one, you could of course just use an RGB LED, and in that case you'd be able to dial up 7 different colors. Now admittedly that's not the fanciest display, but it's a good start for getting to work with liquid crystal displays and touchscreens, and the next time we work with touchscreens we'll look at adding some additional controls onto our display. Well, we've covered quite a bit today, haven't we? We've learned how touchscreens work and the difference between resistive and capacitive touchscreens. We've also used a common touchscreen shield for the Arduino with both the Uno and the Mega, and we've written our own simple touchscreen interface. Now, this is not the last time we're going to be looking at touchscreen displays. I've got another display to show you for a future video, which is a capacitive touchscreen from Adafruit, and we'll be using it along with a number of other different libraries when we work with that one. Also, I've got a touchscreen that works with the Raspberry Pi. It's basically based upon the same module as the one that you've seen right now. It's a resistive touchscreen, but of course with the Pi we need to work with Python, and so I will show you how to work with that display as well. So if you're not subscribed to this YouTube channel, please do so, and then you'll know when these videos are coming up. Now, if you need more information about what we discussed today, please check out the article on the DronebotWorkshop.com website. You will find a link to that right below this video. While you're on the website, please consider subscribing to the newsletter if you haven't already. That way I can keep in touch with you, let you know what's going on in the workshop, and also get your opinion as to what subjects you'd like to see me cover. And if you want to discuss what we've done today, the best way to do that is on the new DroneBot Workshop forums, forum.dronebotworkshop.com. Go to the forums, sign up, and you can get in on the discussion if you've got questions about touchscreens or anything related to Arduinos, Raspberry Pis, robotics, IoT. Well, the forum is the place to ask them, so I'm looking forward to interacting with you there. So until next time we meet, please take care of yourselves, and I hope to see you very soon here in the DroneBot Workshop. Goodbye for now.